Welcome everybody. How is going on? So today we're going to talk about a sorting algorithm. So we're going to actually cover all the sorting algorithms. So on basic sorting algorithm, things about bubble sorting and the bubble sorting. How is it called? I mean, how the name came from? The name came from like when the bubbles is sorting, it's like a bubble in the water. You can see the bubbles. This is like it compares the every next elements and so on and until to the end, and when it's finished that means one element is sorted from the right side and coming the rest round. So it's like so on and so on. That means this is more look like a bubble sorting, like you know, like how the bubbles are uh, generating in the water. So this is how it came from, and well, I'm gonna show about a simulation or animation how the bubble sorting works, and then we're gonna go directly to the code, so we can actually try to make as much simpler as possible this code to make it happen. Let's go on. So I share my screen. Uh, yeah. So here we have all the unsorted data. So we wanted to sort this um, we want to sort this sequence to the ascending order. Let's see how it starts. So first it compares with yeah 8 to 9, and then 9 came last, and then 9 uh, it it compares again with 9 with say 7, that is like already sorted. If you see here every next element, this is look like a bubble, right? And then yeah, 9 is already sorted, so 9 is out of the order. We have to take it out, and yeah, that's how the next round comes, and this round will get assorted data also, right? So we get 8, right? This is how we can do sorting. So at the end it will be like all the sorted order. So I think we got the idea. Let's dive into the code. And yeah, so I have already written the test codes, and now we need to, I'm gonna show my screen. Yeah, so I wrote the test codes for getting the bubble sort. This is the simplest algorithm, so try to develop it in Java, right? Okay, so we got the code here, array here, and for that array what we have to do, first of all we just have to look through it. Well, uh, this array until the it's like until it's not sorted. It's sorted. If it's not sorted, then it will go through this, right? And inside that loop, actually first we are gonna say this is true. Okay, we just declare it before. Boolean sorted equal to false, right? So now in the inside the loop, we say this is always true. It's like this is like a flag. We're gonna use it as when, for example, inside the loop, when nothing to get sorted anymore, then I think this flag will gonna help. Well, finally we put everything in the same array, and now in for loop we're doing like this. Well, let's see, can we get any help from the system? Yeah, add the length. Yeah, so we still should be a little bit -1 because we're gonna compare until end with every next on. So if array I is bigger than array I plus on, yeah, then we're gonna make the swap with I plus 1 the array. Provide to the method and it will do the swap for us. Well, so this is one thing, and when it's sorted, when it does this operation, you'll tell him that sorted is false. That means when this is not coming inside this if, that means this is sorted already, right? This is one part, and the other part was like we need to eliminate one every time. So we say integer index to exclude or eliminate equals 0. First we say 0, and then after every time every loop happens, it's like every iterations, we just exclude one more, and this is gonna add in there here minus. So every time it will reduce this one more row, or how to say one more number in the right side is just exclude. That's it. Actually, it's so simple. So simple. It's like that. Only have to swap it now. Swapping is like as always. We say integer temp is equal array. For example, if I take array I, and then in the array I, and then we say array I is equal array j, and then finally z equal 1. Okay, that's it. So you should do the first array I, we put it inside the temp, and then array I take the data from array j, and then array j take this. That should do the the swapping. So let's see if all the tests are passing now. Hopefully. Yeah, so all of our tests are passing. So that means this works. And yeah, the implementation is quite simple. There's nothing to do. We can recap once again. So it's just if it's sorted, then it will stop going inside. Otherwise, it will make multiple iterations, and every iterations is gonna take on index out of the it's like considered like sorted on. And so the cost, it will require like memory. For the space perspective, we don't use much space here. It's like O of 1, we can say, and the time complexity should be like n square, because we just every time we just multiple. It can be like n square actually. In best case, it can be in log n, but normally it's n square. So that was it actually. So until then, have a good time. We'll come back with some new other sorting algorithms. Until then, have a good time. Bye bye.